Okay, we're continuing 4.4 here, and so we just got done solving exponential equations. And so now what we're going to do is we're going to move on and solve logarithmic equations. So right here, we're going to solve each logarithmic equation. Be sure to reject any x values that is not in the domain of the original logarithmic expression or expressions. Give the exact answer, and then, where necessary, use a calculator to obtain a decimal approximation correct to 3 decimal places. So here's our hint to get started. Isolate the logarithm and convert to exponential form. And so these first two right here are ready to go. They're already isolated. If we scroll down, those are isolated too. So maybe we'll see one that's not ready yet. But these two are good to go. So what we're going to do is we're converting from log form. So log base b of x equals y. That's equivalent to writing it as b to the power of y equals x. So you can just kind of rearrange the terms. Another little trick that you can do here is it's kind of like the one-to-one property. I'm going to go back to that so we can review that. So the one-to-one property is where if you have common bases, you can just set um, the exponents equal to each other. Well, you can actually go in reverse and insert bases if you want to. And that's what we're going to do here because it makes it a little bit easier here. So what we're going to do is, if you notice, my logarithm is base 3. And so what I'm going to do is I'm going to insert a base on both of these. And now those are actually my exponents. And what I'm going to do here is we have a property here where if you have a base raised to a log of the same base, and you're evaluating, we'll say x, that just simplifies into x. It just simplifies into what's right there. So what I'm doing here is I'm inserting a base 3 on both of these. And what will happen is that basically goes away, and I'm going to be left with x equals 3 to the power of 4, which is 81. 3 times 3 times 3 times 3 is 81, and that's my answer. The the same thing would happen if I would do the conversion. So if you prefer to do the conversion, that's fine. You would have 3 to the power of 4 equals x. So the two sides would just be switched. That's the only difference that would occur there. And so, anyways, a lot of people like to do this just kind of as a shortcut. So for on B right here, what I'm going to do is I'm just going to insert a base 4 on both of these. And so then what will happen is that will cancel out, and I'm just left with this. So I have 3x plus 5 equals 4 to the power of 3. And so 4 to the power of 3 is going to give us 64. So now I have 3x plus 5 equals 64. And then we'll go ahead and subtract 5 from both sides. And so we're going to get 3x equals 59. And then we'll go ahead and divide by 3 on both sides. And I'm just going to leave it like that because it does not divide evenly. So I'm just going to do 59 over 3. Now, one thing I forgot to mention is you do want to check to make sure you're within the domain. And so this first couple, we shouldn't have any issues, but we will run into some problems later on. But what you have to do is check and make sure that whatever your answer is, when you plug it in for x, the parentheses has to stay positive. So obviously, if I plug in 81 right here, that's not a problem. And here, a positive times a positive is positive, plus 5. This is going to stay positive. So if you just recall about our domain has to be I'm sorry, our domain doesn't have to be positive, but what we evaluate has to be positive inside these parentheses. And so just a quick check, you can just tell by a positive times a positive plus a positive, there's no issues. Um, so like I said, these first couple we shouldn't have any problems, but later on we might run into one or two problems where the answer solutions do not work. And so that's kind of what they were alluding to up here about rejecting values that are not within the domain. So continuing on down here, now we're going to have natural logs. So we're going to have base E. So I'm going to do that same little trick. I'm going to do a base e here, a base e there. And then so what happens is that will simplify into just x minus 5 equals e to the power of 4. And then we'll add 5 to both sides. And so we're going to have x equals e to the power of 4 plus 5. And so that is my exact answer. And then if I want my my estimate, now I'm going to go ahead and put this in the calculator and let that do that work for me. And let me grab my calculator real quick. So here we go. So I'm going to press second, and if I press the second LN button, it will give me e to the power of, and so I'm ready to put that 4 in there, close it, and then I have to put that plus 5, and it's very important to close that parentheses. And so I'm going to get 59.598. So 59.598. And there we go. And so D is going to be pretty much done the same way. So we're going to introduce a base E. And so then I can cancel that out on the left where I'm left with 4x plus 1 equals e to the power of 3. And then we'll go ahead and subtract 1 from both sides. And then now I need to divide by 4 on both sides. And so this is my exact answer, e to the power of 3 minus 1 divided by 4. Now this is important. When I put this in the calculator, uh, I need to put the numerator in parentheses or else my calculator will only divide the 1 by 4. But if I want to divide the whole thing by 4, when we put this in the calculator, I need to start with a parentheses and then e to the power of 3, close that parentheses for my exponent, then put a minus 1, then close that original parentheses that I opened at the beginning, and then divide by 4. So let's see, we're going to get 4.771. And there we go. Okay, let's look at, oh, let me go back real quick and just point out that these answers are good because that does not mess with me evaluating my logarithm at a non-positive value. So 59 take away 5 is positive, I'm fine there. And then once again here, a positive times 4 plus 1, there's not any issues. So I haven't had any issues yet. Now what we're going to do here is I'm going to have multiple rhythm expressions within the equation, and what we have to do is condense them and then basically do the same thing we were doing on the previous page. So this is when it's going to get a little bit more interesting. So when I condense this, I'm going to multiply those together, and so I'm going to end up with log base 4 of x squared plus 30x because I'm multiplying the x times x plus 30. So that gives me x squared plus 30x equals 3. And then we're doing the same thing we did earlier. I'm going to insert a base on both sides of 4. And I chose 4 because that's the base of my log so that I can go ahead and reduce this, the left side, down to just an x squared plus 30x equals. And then 4 to the power of 3 is 64. Okay, well, this is weird. I haven't seen this in a while, but what this is a quadratic equation. And so what I want to do here, because I've got the x squared, I'm going to set this equal to 0 and see if, see if I can factor this. So let's see. So I'm going to end up with, and I'm going to move this up here. So I'm going to end up with x squared plus 30x minus 64 equals 0. And now I have to find two numbers that will multiply to give me negative 64, but add up to positive 30. And so we've done this before, and you kind of have to play around with this. And so I know it's a positive and a negative because they multiply to give me a negative, but they add to a positive, so the larger number is positive. So let's see, like positive 64 times negative 1, but that doesn't add up to 30. So then my next one would be what? Let's see, 32 times negative 2. Well, that multiplies to give me negative 64, and it adds to give me 30. So yes, that's the pair that I want to use here. So we're going to factor this into x plus 32 times x minus 2 equals 0. It doesn't matter where I could have put the minus 2 first and then the plus 32. But either way, I've got my two factors. And so now we're going to take each factor because we're trying to figure out what makes this equal 0. And this is kind of a review back from our first unit that involved solving quadratics. If I can figure out whatever makes each individual factor equal 0, it causes the whole left side of the equation to equal 0. So I take each factor, set it equal to 0, and solve. And so let's see over here, I'm going to subtract 32 from both sides, and I get x equals negative 32. Over here, we'll add 2 to both sides, and I get x equals 2. So these are my two possible solutions. Now, this is what could happen. They could both work, they could both not work, or one of them could work and one doesn't work. That's what happens most of the time. Not all the time, but most of the time, one of them works and one doesn't work. And so the negative 32 is not going to work because if I plug it in, I cannot evaluate logs at negative values. So that's not going to work. So I know negative 32 does not work. So I got to reject it. Now, positive 2 doesn't cause an issue. If I plug in 2, that's great. If I plug in 2 here, that's not a problem. And so 2 is actually my only solution that works. So I have to reject the negative 32. Okay, let's try another one of these. Example B is going to be very similar, except that I'm actually going to have to foil these. I'm going to have to foil that. I'm going to have to foil it when I bring it together. So I'm going to bring it together as a single log base 3. And when I foil it, let's see, x times x is x squared, x times 4 is plus 4x, 6 times x is plus 6x, and then 6 times 4 is 24. So that's that part of that. Then equals 1. And so now what I'm going to do is insert a base 3 on both sides. And when I cancel or reduce the left side down, I'm going to go ahead and also combine those like terms just to go ahead and take care of that part of it. And so now I'm left with an x squared, and then this would become a plus 10x. Then I have the plus 24 right there. And then equals 3 to the power of 1 is just going to be a 3 right there. And so just kind of review. So I foiled and inserted a base of 3 on both sides. I did go ahead and combine my like terms in the middle right there to get that 10x. Now it's time to set this equal to 0 and see if we can factor this. So once again, I'm going to pull it up over here. So let's see, x squared plus 10x plus 21 equals 0. And so now I have to find two numbers that multiply to give me 21, but add to give me 10. And so I believe that's going to be 7 and 3. 7 times 3 is 21, and those numbers add up to 10. So that will factor this into x plus 7, x plus 3. And then just like the previous one, we'll take each factor and set them equal to 0. And solve. So one of my possible, I use the word possible, solutions is negative 7. And another possible solution is negative 3. But now it's time to check and see if either one of these are going to cause any problems. And the negative 7 is going to cause a problem. Because when I plug in negative 7 plus 6 is a negative value. Right away, I can just stop there and be like, okay, it doesn't work. But it also causes an issue in the other one also. But it just has to be a problem anywhere within the problem, you automatically are going to reject it. So for example, let's say that I had x equals negative 5. Well, it wouldn't be a problem for the first one, but it would be a problem for the other one, so I would have to exclude it. Now, that was just an extra example there. Now let's look at the negative 3. If I plug in negative 3 plus 6 is a positive number, so I'm okay. And then negative 3 plus 4 is a positive number, so I'm okay. So negative 3 will work for us. Okay, moving on. In example C, we're going to be using the quotient rule. So because we have subtraction here. So this is going to come together as log base 3 of x plus 4 divided by x equals 2. So I had to do the quotient rule here. And so then we're going to insert a base 3 on both sides. And so the left side is going to simplify into just an x plus 4 over x equals, and then 3 to the power of 2 is 9. And then here we just need to solve for x. So first thing I want to do is get rid of my fraction. So I'm going to multiply both sides by x, and that should take care of that fraction on the left side because the x's will cancel out. And I'll be left with x plus 4 equals 9x. And then I will subtract both sides by x. And then I'm left with 4 equals 8x. And then we'll go ahead and divide by 8 on both sides. And I end up getting 1/2 equals x. And then once again, just take a moment to kind of think, okay, if I plug that in, does it cause a problem? And it does not. When I plug in 1/2, I'm okay. A half plus a fourth, it's still positive. And then a half is a positive number, so I'm good to go. So that does work. Okay, so we have one more page of examples kind of similar to this, but now what we're going to see is we're going to have the logarithms on both sides. And so what we have to do is get a single log on each side and then use the one-to-one property to cancel out the logs. So what we're going to do here is if we can get, uh, like example A is ready to go, I can just go ahead and, because I'm just focused on getting those two parts to equal each other, because I have log base 4 on both sides, so I can just go ahead and remove them, and I'm left with 7 equals 4x plus 13, and then we just have to solve this. And then obviously check to make sure it's within my domain. So I'm going to subtract 13 from both sides. So I'm going to get, what is that going to be? Negative 6 equals 4x. And then we'll divide by 4 on both sides. And so this reduces to a negative 3 over 2 equals x. Okay, and so you might be concerned because x is negative, but we're going to be okay. This answer will work. This answer will work. Basically, as a fraction or as a decimal, it's negative 1.5. And so there's nothing to plug into the first logarithm. And if you plug it in here, that would give us negative 6, but you're going to add 13 to it to where the within the parentheses, what I'm going to evaluate on the right side will be a positive number. So I'm okay actually with that. The negative 1.5 is not going to cause a problem. So that either one of those is fine. Negative 3 over 2, or if you want to write it as negative 1.5. Now on example B, I can't just be like, oh, I'll just cancel out all the natural logs. We can't do that, okay? The formula is referred to as the one-to-one property. So what I'm going to have to do is first I'm going to have to condense this and then apply the one-to-one property. And so I have to do the product rule first, which means I'm going to multiply that x to both of these. So I'm going to end up with the natural log of x squared minus 3x equals the natural log of 5x. Now I can remove the natural logs and just focus on solving x squared minus 3x equals 5x. So then what I'm going to do is set this equal to 0 by subtracting 5x from both sides. And I'm left with x squared minus 8x equals 0. And then I can, this is a little different factoring than the other ones we've seen so far. I can actually pull out a GCF, which would be x. So x times x minus 8 equals 0. And so these two things are getting multiplied together. And so if this one's easy, if x equals 0, that would cause the left side to be 0, which would make a true statement, right? And then I'm kind of running out of room, so I'm just going to do this in my head. My other one would be positive 8. If I were to plug in positive 8, I'd get 8 times, this would become a 0, which then 8 times 0 would be 0. So those are my two possible solutions. But 0 is not going to work. Okay, so 0 is not going to work. And it doesn't work anywhere in here because you can't evaluate logs at 0. It has to be positive, so it causes an issue. Like I said, it only has to cause an issue in one place, and then automatically you can't use it. So zero is not going to work. What about 8? Let's see. 8 would be okay here. 8 take away 3 is positive. That's a 5, so that's okay. And then 5 times 8 is a positive number, so 8 works. So 8 is good to go. We cannot use 0. And if you're unsure about that, you can even try to put it in the calculator and you'll see it's going to say error. So I'll just show you real quick. So if you try to put in natural log of 0, it's going to come back and say error, domain error, because we're out of the domain right here. Okay, we got a couple left here. So we got 2 to go. So right here, we're going to go ahead. I'm going to have to FOIL this again. So I'm going to have to FOIL this. So I'm going to FOIL these two parts together. So let's see what we get here. So we're going to have log base 12 of, so this is going to become an x squared plus an x, then minus 6x, and minus 6 is equal to 2. And so actually, this looks like I actually mixed this up. This should have been on the previous page, but we'll go ahead and finish this one because this isn't going to have that one-to-one property in it. So what we'll do here is we'll go ahead and combine that right there. And so let's see, we're going to have log base 12 of x squared, and then let's see, minus 5x minus 6 equals 2. And then we're going to insert a base 12 on both sides. And so what we'll do here is that's going to cancel out. And we're left with x squared minus 5x minus 6 equals 12 to the power of 2. 12 times 12 is 144. And then what we'll do is we'll subtract 144 from both sides. And let's see, we're going to have x squared minus 5x minus 150 equals 0. And then we're going to play our little game here where we're trying to figure out what multiplies to give me negative 150. But when I add those two numbers together, they add up to negative 5. So you can play around with it a little bit, but you'll eventually get to negative 10, I'm sorry, negative 15 times positive 10. So negative 15 times positive 10 is a negative 150, and then those two numbers add up to negative 5 right there. So this is going to factor into x minus 15 times x plus 10 equals 0. And then we solve each one of these. And so this first one would be positive 15. And then the second, if you set that factor equal to 0 and solve, would be negative 10. So those are my two possible solutions. But I'm going to have to reject the negative 10 because if I plug in negative 10, it's going to cause me to evaluate the logarithm at a negative value, and that's no good. 15 looks like it's good to go. Okay, our last one. Now this is back to the ones where we have the one-to-one properties going on here. And so I need to go ahead and condense this, and it's going to be the quotient rule. So I'm going to have log base 8 of 11x plus 4 divided by 9, and then equals log base 8 of x plus 6. And then what we can do here is we're just going to lift up those logs, just kind of take them, because we're really kind of focused on getting the part in parentheses equal to each other. So now we're going to have 11x plus 4 equal, I'm sorry, divide by 9 equals x plus 6. Now, like what we did the last time we had a fraction was we wanted to get rid of it, and so we're going to multiply both sides by 9 in order to accomplish that. So on the left side, the 9's will cancel out, and I'm going to be left with 11x plus 4 equals, and then here I need to distribute that 9 to both parts here. So that's going to give me 9x plus 54. And then from here, I need to solve for x. And then once I get my answer, I just need to make sure that I don't have to reject it. So let's see. We'll start by subtracting 9x from both sides. And so let's see. That'll give me 2x plus 4 equals 54. And then we'll subtract by 4 on both sides. And so we're going to get at 2x equals 50. And then last, we'll divide by 2, and we'll get x equals 25. And I'm hoping that'll be all right, but I'm not positive, so let's go look. See, 25, if I multiply by 11 and add 4, that looks good. Here, this one's just 9, so I don't worry about it. Then 25 plus 6 looks good. So I am good to go. So that solution does work. 25 is good to go. Okay, up next will be the application problems.